Okay, today we're going to talk about mineral corticoids, which the main mineral corticoid is aldosterone. So we're going to take a look at the typical things. As far as disorders go, we're just going to look at some overall general disorders. Not really disorders, but what goes wrong when you have aldosterone. So not really naming things, just how it affects the heart, things like that. So mineral corticoids are, again, a type of corticosteroid. So there are many types of corticosteroids. Mineral corticoids just falls under one of those. Mineral corticoids are produced in the adrenal cortex, specifically in the zona glomerulosa region. Now, when you're looking at the cortex, as you go from superficial to deep, the zona glomerulosa is the upper portion of the cortex, and that is where aldosterone, a mineral corticoid, gets secreted. And it's the primary mineral corticoid, right? Aldosterone is. So we're just going to mainly be talking about aldosterone instead of all of them. The zona fasciculata, this is where cortisol is coming from. And then the zona reticularis, that's actually where the androgens are mostly coming from. And then in the medulla of the adrenal gland, remember, this is where you have epinephrine and norepinephrine being secreted. So again, just looking at corticosteroids in general, you've got two main types: glucocorticoids, which is in a different discussion. And then today we're going to take a look at the mineral corticoid type, which again is produced in the zona glomerulosa of the adrenal cortex. And the primary mineral corticoid that we're going to talk about is aldosterone. So again, just taking a look at some various terms, types of corticosteroids that you've probably heard before. We're going to be in the pink zone today talking about aldosterone. So what is the stimulus for the secretion of aldosterone? Why is it secreted in the first place? Several factors, actually. So if you have too much potassium in the blood, high levels of potassium, that will trigger the release of aldosterone. Another trigger, a huge trigger that we're going to mainly spend time on, is the presence of this substance called angiotensin 2. We're not going to worry about angiotensin 3. But angiotensin 2, if it's present in the blood, it will cause the secretion of aldosterone. And then in the cortisol discussion, we talk about how ACTH tends to also cause the production or the release of aldosterone as well. So just kind of an afterthought on that. That kind of ties in both of those lectures. So again, where is it secreted from? Zona glomerulosa of the adrenal cortex. I'm not worried about the percentages. It's kind of neat, though. I mean, if you wanted to look at it, so you know what part of the adrenal gland, how much it's working, what it's secreting, what's the most that it does. So it's kind of neat. You don't have to know that. So where does aldosterone go? What's the target? Now, the main target that we're going to be taking a look at is the kidneys. So this is just kind of more FYI. We're going to take a look at as far as the effects of aldosterone on some of these structures over here. But for test purposes, where does aldosterone target? It goes to the kidneys, specifically the collecting duct and the distal convoluted tubule of the nephron. Now, I know we haven't talked about the nephron yet. That discussion is coming when we get to the urinary system, because the nephron is the main functioning unit of the kidney. And the kidney's job is to filter blood from waste. So that way you've got fresh blood coming in and the waste is going to go out in the form of urine. So it's the filtering component of the kidney. So we're going to talk a lot about the nephron. So it's okay if we kind of discuss it a little bit now, even though we haven't officially talked about it. So what you're looking at on your screen now is the nephron. It is the functional unit of the kidney that filters blood. When we're talking about where aldosterone acts, we know it acts on the nephron, specifically the distal convoluted tubule and the collecting duct. So what happens is the blood comes in to this area here. So this is where the blood comes in. This is the starting point over here in the glomerulus. The blood gets filtered. waste follows these arrows through the proximal convoluted tubule. If you remember your terminology, proximal means closer to, distal means further away. Well, what are we closer to? We're closer to where the filtration occurred. We're closer to the glomerulus. So it's the proximal convoluted means curvy. So it's the proximal convoluted tubule. We're going to go down the loop of Henle. We're going to come up and we're going to be in the distal convoluted tubule. So this is one place where aldosterone acts. From there, the material is going to go into the collecting duct. And that's the other place that aldosterone is going to act, is on the collecting duct. Now, from the collecting duct, we're actually going to call what's in this urine at this point, and it is going to go to the bladder. So this is where it's going at this point. The distal convoluted tubule and the collecting duct are at the end of the filtration process. Okay, so these are the two areas where aldosterone is going to act. What does the kidney do now that aldosterone has showed up? What does it cause to happen? Now, along this nephron, we have a lot of things moving in and moving out in different sections of the nephron. So when aldosterone shows up, what it does is it puts sodium back in the blood. So we remove the sodium from the nephron and return it to the blood is what happens when aldosterone shows up. Now, keep in mind, go back to anatomy 1, water follows sodium. So wherever sodium goes, water is going to go as well. So if you increase sodium retention in the blood, by default, you are also increasing water retention in the blood. So if the blood sodium levels go up, the increase of water in the blood also goes up. Water follows sodium. It does whatever sodium does. Now, with the reverse of that, sodium and potassium do the opposite. Remember your sodium-potassium pump. You've got 3 sodiums moving out, 2 potassiums moving in. They're going to do the opposite. They're still doing the opposite here. Nothing has changed. We're actually utilizing the sodium-potassium pump to get these ions on the right place, in the right place. So if sodium is going into the blood, that means potassium is leaving the blood and going out in the urine. Remember what one of the triggers was, the stimulus? Too much potassium in the blood. So we got to get the potassium out. So this is, careful on your words here, right? Increased potassium secretion. Okay, where the other two are retention, meaning we're retaining these things in the blood. So secretion, we're getting it out of the body. So it's going to go into the nephron and out through the bladder and gone. Okay. So what is the ultimate result? Well, we've taken sodium and put it back in the blood, and we know that water follows sodium. So because sodium is now in the blood, so is water. Water causes an increase in blood volume, right? We just put a bunch of water back in the blood. So we're going to increase blood volume. What does an increase in blood volume result in? Increased blood pressure. So if you increase blood volume, ultimately you're increasing blood pressure. So what does aldosterone do? It increases blood pressure and causes an increase of sodium in the blood. Those are the two big things. So kind of looking at this as a big picture, and we're going to start talking about angiotensin a little bit. You can kind of see it in the picture here. So we're going to start here. I had to kind of put a starting spot because this picture is kind of looking like I don't even know where to begin. Blood pressure falls. So this is your trigger, but again, not the trigger for aldosterone secretion. We just have a drop in blood pressure. Now, this causes a chain of events to happen. So when blood pressure falls, the kidney picks up on that and it secretes renin. Remember, renin was one of the hormones that we learned back in chapter 17 that is secreted from the kidney. Now, renin, when renin shows up in the blood, angiotensinogen is already in the blood. When renin shows up, angiotensinogen gets converted to angiotensin 1. As angiotensin 1 passes through the lungs, this enzyme, ACE, causes angiotensin 1 to get converted to angiotensin 2. Now, this is the biggie, right? Angiotensin 2. When angiotensin 2 shows up on the scene, that's when everything happens. One of those things that happens is it affects the adrenal gland and causes the secretion of aldosterone. Remember, that was one of the triggers of aldosterone secretion was the presence of angiotensin 2. So angiotensin 2 causes the secretion of aldosterone from the kidney, or from the adrenal gland. Aldosterone acts on the kidney by retaining salt, ultimately an increase in water as well in the blood. And that causes a rise in blood pressure. What type of hormone is aldosterone? It kind of has it in the name, right? Sterone. So it is a type of lipid. It's a steroid hormone. There's your 4-ring structure right there. Now, this is the overall pathway, the renin, angiotensin, aldosterone axis. So this is showing you that domino effect of events that occurs. And we're going to talk more about this in class when we get into blood pressure and things like that. But just to kind of walk you through this, because this is kind of scary looking, just to kind of walk you through this a little bit. The liver, we're going to start here. Okay. So the liver constantly produces angiotensinogen, right? I mean, what else would produce angiotensinogen but the liver? The liver produces everything. Like I said, if when in doubt, it's coming from the liver. Now, when you have a drop in blood pressure, the juxtaglomerular cells, that's what JG stands for, juxtaglomerular cells of the kidney produce renin. Renin gets added to the blood, and that causes angiotensinogen to get converted to angiotensin 1. Now, as angiotensin 1, it's in the blood, it just passes through all the organs. As it passes through the lungs and meets up with the ACE enzyme, angiotensin converting enzyme, that's what it stands for, angiotensin converting enzyme. When it passes through the lungs, it encounters the angiotensin converting enzyme. So angiotensin 1 gets converted to angiotensin 2. You may have heard people who take ACE inhibitors. People who take ACE inhibitors take them because they have high blood pressure. Well, if angiotensin 2 is the trigger which results in increased blood pressure, if we can stop angiotensin 2 from being made, we can stop the blood pressure rising. So, where we stop this chain of events from occurring in people who have high blood pressure is to block that enzyme right there. Angiotensin 1 is in the blood. It never gets converted to angiotensin 2 because you have an ACE inhibitor. Just kind of FYI there. So this is where we block that chain of events in people that automatically have high blood pressure. So, but we're assuming you don't have high blood pressure. So in that scenario, let me just kind of get rid of that there because we're saying we don't have high blood pressure. So we're going to go ahead and go with the regular chain of events. So angiotensin 2, we now have in the plasma floating around. And as you can see, angiotensin 2 affects many structures. We're only going to look at, for this particular discussion for aldosterone, we're going to have it affect the adrenal cortex, right? Because that's where aldosterone gets secreted from when angiotensin 2 shows up. So angiotensin 2 shows up, the adrenal cortex secrete aldosterone. That causes sodium reabsorption in the kidneys, which means we're going to put sodium back in the blood. And you know where sodium goes, water follows. So that is going to cause an increase in volume of the blood, which will result in an increase in blood pressure. Now, as you can see with angiotensin 2, that's only one way that it's going to cause an increase in blood pressure. Basically, if angiotensin 2 is present, you're going to get an increase in blood pressure one way or another because there's so many different things that are going to ultimately result in that increased blood pressure. So what are some adverse effects of aldosterone, increased aldosterone versus, and which ultimately is an increase in salt, sodium in the blood? So you can see that they have a lot of damaging effects. So things like hypertension, high blood pressure, vascular injury. It's going to injure the blood vessels, and left ventricle hypertrophy. It's going to enlarge the heart. So Yes, you all know that too much salt in your diet is bad. Now you can kind of see what ends up happening and why increased salt leads to heart attack and things like that. Now, again, some cardiovascular effects of aldosterone. Again, just some very negative things here. So it does affect blood vessels, it affects the brain, it affects the kidneys, and it affects the heart. So having too much salt because of too much aldosterone affects many different organs. So you've got things like hypertension, which is high blood pressure, atherosclerosis, clogging of the arteries, ischemia, low blood to an area, infarction. You've basically killed, again, that area. Hypertension, stroke on the brain. So too much blood pressure in the brain. Hypertension in the kidneys, too much blood pressure going in, which is going to result in renal failure, which could result in heart failure. And then heart failure, sudden death, MI, myocardial infarction. So again, all bad things when you have too much aldosterone which ultimately results in too much sodium in the blood. And I've put on here, and you guys should be able to find this on your own if you're looking for it, but these are the titles of these videos if you wanted to go a little bit further, talking about how aldosterone raises blood pressure and lowers potassium. It's from Khan Academy. Awesome videos. They're free of charge. And then also a 9-minute video on aldosterone and anti-diuretic hormone, which I mentioned previously when we actually talked about anti-diuretic hormone. So I think that's actually on your one on your page on anti-diuretic hormone. I've put that link to that video there. So that's all for that, and that's quite a bit. Aldosterone, that's quite a bit.